be your host for today. And today we're looking at selecting the right replacement hose assembly, and we're looking at two aspects of the industry specifications and the stamped method to get this system working and selecting the right hose replacement. All right, so a fortnight ago we discussed the construction of the hose. So we ran through the tube, the reinforcement and the cover. Now, with each of these components, they have different variations for different reasons. So the tube, which conveys the fluid, obviously needs to be matched to the correct type of fluid, operating temperature, which is required for that system. The reinforcement, which provides the resistance to the pressure and the impulses of the system, gives the grunt to hold the hose together. And then the cover protects the tube and the reinforcement, but also we need to be aware of conditions which that's going to be exposed to, which is abrasion, heat, ozone, etc. We also went through some troubleshooting with the hydraulic hoses and how to make some corrective actions for getting the correct assembly in place. And we discussed regarding techniques about value-adding products, whether it be upgrading the outer cover type or adding in some outer cover protection in the types of sleeves or wraps to maximise the hose life. So at the end of today's session, what you'll be able to do is describe the purpose, the logic behind the industry standards. So we'll discuss SAE and the ISO side of things, and follow the stamped procedures to select the perfect and correct hydraulic hose for that application. So let's get in and have a look at the industry standards. So we'll have a look at the Gates ley lines and we'll discuss how we decode these. Every hose has a lot of information, so it's good to go through a step-by-step to understand what these are. So the hose description is something which is starting over here on the right-hand side. So for our example here, we've got our 12 MXG hose, which we're looking at today. So that's clearly identified as the hose, as the part number. Just below that, you have the product family name, which comes under the extra tough cover side of things. Then below that, with the Gates icon for the GS coupling, the global spiral, gives us the indication on what coupling is applicable for this hose range. Of course, we have a Gates logo for branding purposes and information from there. Near the bottom there, on the left and the right-hand side, we've got the size. So it's a 3/4 inch ID hose or 19mm ID. So we have that both in metric and imperial. And along with that, we have a pressure rating. So as you can see here, this hose has a pressure rating of 4,060 PSI. Now, the next one along is probably one of the important ones, is the industry specifications. Now, this covers off the SAE, ISO, and EN, which is European norm ratings. So there's a lot of information on there to indicate what the hose meets and exceeds in respects to those international type standards. Also on the hose, more on the back of it, so around about 90 to 180 degrees, there's some further information which is more relating to the item itself and how that works. So it's the date code for when the hose was manufactured, the plant and country of origin for tracking purposes, and also the shift that it was manufactured on. This is all there, so if there's ever an issue, it can be traced back and pinpointed to where that issue is. So there's, as I said, there's a lot of information on there. There's also other bits on the hoses for the MSHA approval side of things, which obviously says the hose meets a specific standard for that side of it. Now, with the industry standards, there's a couple of ones we're going to highlight here, which will go through the SAE and EN, which the SAE and EN standards are very, very similar, and then the ISO specifications. So initially, we'll have a look at the left-hand table with the SAE specifications. Now, this is a construction-driven standard. So as you can see there, the construction's outlined for what is required for a SAE 100R1 hose, which is a one-wire braid, has to withstand the impulse test cycles of 150,000 and temperature up to 212 Fahrenheit. Now, for the people who not too good and on one of those, hand up for converting the Fahrenheit to Celsius. The bottom right-hand corner is just a bit of a table for what the different temperatures relate to, back to what we refer to locally here. So as you can see, as the different ranges of hose, an R2 hose is a 2-wire braid. An R4 hose is, generally speaking, your suction delivery hoses, which is one helical wire inside that hose there, with a bit of fabric reinforcement generally. R7 is a single textile braid reinforced hose, and an R8 is a 2 textile braid. Then we go into our spiral range of hoses. 100 R12 meets 500,000 impulse cycles as a 4 spiral wire. And then for the R13 and R15, we have some variations in the construction coming in. So in the smaller sizes, you have 4 spiral wires. For the larger sizes, you get 6 spiral wires to meet the impulse cycle requirement for that. R16 and R17 hoses, again, have 2 variations in the construction between a 1 and a 2 wire. Obviously 1 wire for the smaller ID, then 2 wire when we get to the larger IDs. Also R18, which is a 1 or a 2 textile braid thermoplastic, and then R19 back to a 1 or a 2 wire braid construction. So looking at that and then comparing over to the right-hand side table, which is the ISO standard, which is purely a pressure-driven standard. If you look at the left-hand side column of that table, it indicates all the different pressure ranges. And then we go to 4 different grades. So grade A is a 200,000 impulse, grade B is 500 at 212 degrees, which is 100 degrees. Excuse me. Grade C is 500,000 again, but it's increased in temperature to 121 degrees Celsius. In grade D, we have 1 million impulse cycles at 121 degrees. Now, the construction of these hoses is variable, and this is left open to the manufacturer to decide how they're going to meet those particular impulse test cycles and the temperature ranges. So when comparing the 2 sides of it, excuse me, the SAE under the 3 main criteria, so construction is identified, performance and the impulse cycles is identified, and the pressure ratings are variable. Whereas we look at the ISO standard, the performance is confirmed and the different grades for the impulse testing. The pressures are confirmed for what they need to meet, but the construction is variable. So it gives the manufacturers a larger scope on what they can do to meet those requirements. So these are the 2, along with the EN, which is again similar to the SAE, which the industry works towards for construction of hose and the industry standards around them. So now looking in more of the Gates range with the Megasys series of hose with the SAE specifications and the different colour tables there. So what different hoses meet the different SAE specifications and where they fall into the chart. So as you can see, blue is obviously M3Ks, so that's the SAE 100 1 hose, and then some of those cross over to the SAE 100 R2. So there's a lot of crossover for some hoses, as you'll see in a lot of the boxes there. There's 2 hoses which meet the specifications for that. Okay, looking into the stamped system. So this is something which we use when you cannot identify the hose. So this is when you may remove a hose from a machine or a customer brings the hose into the shop and there's no markings on the lay line, there's no information you've got there. So the first thing to go to do is obviously you clean the outside of a hose. Hopefully either yourself or the customer has done that before bringing it to the assembly area, so it keeps that nice and clean. And you've got to see if there's any descriptive markings, as we were talking about on the lay line. If not, then we do a couple of things. We sort of grind it down the outer cover. There's a couple of ways of doing that with a sharp knife or a wire wheel to expose the reinforcement. And what we're looking at there is the different style of reinforcement, if it's a spiral or if it's a braided steel. Also, then if there's a thermoplastic, you'll notice the difference in those because they're a lot lighter in the construction, and you'll understand the difference when you're holding 2 side by side. Excuse me. Right, so what we then want to do is we want to cut a piece of a hose open and look at the reinforcement. So we want to cut, obviously, in the middle of a hose where we can. A lot of the time you don't have to cut the whole way through. You can go about 2/3 of the way through and just bend the hose over and have a look. And you want to count those layers of reinforcement. So between 1 wire, 2 wire, or in your spiral ranges, 4 or 6 wires. Then we follow through the stamped process. So this is all included in the Gates catalogue, so we can find that on page C1, and it outlines all of these items again. So we look at the size, which is the ID of the hose, temperature, internal and external, application, so what it's exposed to, material, so what fluids we're looking at conveying through the hose, the pressure of the systems, what their spikes are, what it's actually doing, the ends and the delivery side of things. So we're going to go through each of these one by one. We'll start that now. So the size of the hydraulic hoses generally work in dash sizing. So these are in 1/16 of an inch. So a lot of people are familiar with this system, a lot of people aren't. It takes a little bit of time to get some people's head around it. But once you can understand the dash sizes and fractions that are associated with it, that's how we identify the ID of the hoses. So for example, a dash 2 hose is 1/8. Dash 3, 3/16, dash 4 is 1/4, and so forth all the way through for all the different sizes for the standard hydraulic hoses. We also have true bore hoses. Now, these are hoses which are generally in applications, copper or steel tube was originally used, and some automotive applications are very much use what we consider a true bore hose. So these come under the SAE 100R5, which is the Gates C5 series, the SAE 100R14, which is the Gates C14 hose, which is the PTFE style of hose, generally found compressors coming off on trucks, hot environments and that sort of thing. And the AC 134A refrigerant air conditioning hoses, which is the Gates Polar Seal. Excuse me. So pages C1 of the 2019 catalogue has the information for all your dash sizes. We also have those in metric and imperial. All right, looking at the T, which is temperature. So temperature, so it's both the fluid internally and the ambient temperature, which must be considered. As we alluded to in the session 2 weeks ago, an increase of 7 degrees above the maximum temperature will decrease the hose life by up to 50%. Common synthetic rubber covers with nitrile tube has a range of about negative 40 to 100 degrees in wire braid and up to 121 degrees in spiral. We do have high temp and extra high temp versions of a hose. These can go from maximum temperatures of 121 degrees up to just shy of 150 degrees. So these normally are return lines where things are very, very hot or environmental sort of environments where the temperatures externally can get very, very warm. We also offer a low temp version, probably not applicable for a lot of places around Australia, but it can go down as low as negative 56 to 57 degrees. And that's available in both wire braid and spiral reinforcement. There have been some inquiries lately for this range of hose for equipment being manufactured here in Australia, heading up to Canada and North America. So we do see this stuff, and it's just always good to ask what the temperature range and have an understanding of that when selecting the right hose. Okay, also looking here at the application considerations here. Again, we're talking about temperature and what can happen to the hose, start cracking and failing internally due to the liner being effectively overheated. Safety risks that we need to consider too for proximity to the operator. Australia has the MDG 41 guideline, which we follow for fluid power products. So you've got to look for line of sight for how close the customer is to that sort of thing. The picture to the right there is off a loader, and obviously the hose has failed there, and it's actually gone through glass on the cab. So it's something to consider if there needs to be a diffusion sleeve fitted to that hose to prevent that sort of thing or potential injury happening to the operator. We've obviously got routing considerations. If we're rubbing up against something and the outer cover is compromised, then the reinforcement will soon be compromised. So we need to either make the hose longer or add a different abrasion resistance there to prevent that from happening. So yeah, there's a few things to consider about where the hoses are running and the temperatures and what can be done to protect people and ensure their safety. Okay, here's a couple of examples of incorrect application choices here. So we'll start with the top left. So this one here, the customer selected a jacking hose, a J2AT hose, which has a 10,000 PSI static rating for its pressure. It was put into a high pressure dynamic application where the pressure was increasing and decreasing considerably a lot over a time frame, resulting in a catastrophic failure and injury to personnel. So it's picking the right hose for the pressure variations would have prevented this from happening. Bottom left here, we have a picture of the coupling in a hose which is separated. So the customer crimped on the coupling to a different manufacturer's hose. So it comes under the mixing and matching, which we never recommend. We're attempting to guess the crimp spec, and the result was, again, the hose failed, and yeah, it was a lawsuit which followed that by all accounts. So we always only put a Gates coupling onto a Gates hose. Over to the right, we have two pictures there. This was a mining customer. The mechanic was fatally injured when he was attempting to disconnect the highly corroded connector. So they couldn't remove it the normal fashion, so he was using a hammer to strike the ferrule. Unfortunately, this fractured the ferrule, and when reassembled and then the system was started, the hose blew off and come around and struck the operator, who was unfortunately killed from this. So anything like that, you know, the corrosive environments, is there a way we can go around? Can we wrap? Can we put a stainless steel option in? Can we look at a different way of doing it? But also for the operators to never use a hammer or any other way of trying to remove it if it's not coming apart as intended by the manufacturer. All right, the next one here, for those of you looking at this picture, you can probably identify that it was at one stage a bus. Now, this is the effects of an incorrect hose for the application. So the customer installed the incorrect hose for the application. Over $700,000 of damage was done, personal injury and lawsuits. Okay, this one made live news by all accounts in the US, and the distributor was put out of business due to the incorrect hose for the application. Yeah, it was deemed that the hose was used in a very, very hot environment, which was not rated for that application. For a bit of personal history on this, I had a customer many years ago who I sold some hose to. He told me it was a low pressure hydraulic return line, which we gave to him. He ended up using it as a petrol delivery hose on a fuel injected car with a large turbo. The turbo was very close to the hose. Unfortunately, the hose failed due to the heat and the medium, being the petrol, going through it, and caused the car to burn to the ground. So it was one of the things that I was very clear with and pass on to anyone as we're talking, that itemise what you're supplying to the customer. If you're supplying a low pressure return hose and that's what they're asked for, it had that information on the invoice, because that covered me and saved me going through the process of what was happening there, trying to indicate that the wrong product was supplied. So it's always good to have the information and document what has been requested and what has been provided. Sorry, excuse me, just having a drink of water. Okay, so now we're looking at the M, which relates to the materials being conveyed. So this is what obviously is going through the tube of the hose. So we need to be very specific about this. Okay, is it a petroleum-based fluid? If so, what kind? Is it a biodegradable fluid? If so, what kind? Is it anti-flammable? If so, what kind? If the customer doesn't know, we dive a bit deeper into this, and we get the MSDS for the particular components that we to find out to get the correct liner for the hose to match the chemical. It's not the sort of thing we take lightly, and we make sure we have the right hose for the right application in this instance, because as you can see on the table on the right there, there are different types of hydraulic fluids, the phosphates, ester-based, high standard petroleum fluids, water glycol-based hydraulic fluids, and they all have different resistance ratings for the different internal liners of a hose. So it's always best to ask properly, the right questions, so we're getting the correct hose replacement included. Now, P is the standard one we need to look at is the pressure of the system. So we need to consider all the aspects of the pressure of a hydraulic system. So it's the operating pressures, potential surges, understand what the settings of the relief valves are, and know the nature of the pressure also, because generally speaking, you can have some parts of a system will have a pressure and a very slight vacuum, whereas other systems, components, are vacuum only for the likes of suction hoses. So knowing all this information and understanding that, and also getting an understanding from the operators that they know what the system does, if there's a large amount of impulse spiking or anything like that. And because this can also come back to inspecting the hose for why it's failed. If it's failed due to a pressure spike, it may be that somebody has made a bad copy previously and you're just copying a bad copy, which is just going to end in the same result, unfortunately. So going through the stamp system will get us to ask the question, am I replacing the recommended hose, or am I replacing a bad copy that somebody else has made? Again, still looking through the pressure side of things here. So as we were discussing earlier with the ISO and SAE standards, between the pressure ratings are different between the two styles of design. So we need to look through the gates range, and we have this sort of outlined here on the image. So the variable pressures, obviously the working pressure of the hose changes depending on the hose internal diameter. So the easiest one to look at is probably the very bottom line is a G1H hose, so a one-wire high temp. So we're starting off at in a dash 4 at 2,750 PSI maximum working pressure. When we're getting down to a inch and a half at the dash 24, it's down to 725 PSI. So it's a significant drop across the stages as the hose ID increases. If then we look up a little bit further to the M4K, which is the third one down in the middle section of the box there for constant pressure braid hose, so they're 4,000 PSI. So the dash 4 is 4,000 PSI, and the dash 16, which is a 1-inch hose, is 4,000 PSI. So they're constant across the board. Same as when we're looking at our spiral range, which is in the top section there. So that is from, so for example, the second one down is EFG 6K. From a dash 6 or for 8 is 6,000 PSI, all the way through to inch and a half is 6,000 PSI. So they're just the variations we need to look at and understand in the tables, but also what hose we're picking up. If it's a larger size and a variable pressure, it's going to be a lower. If it's a larger size and a constant pressure, it's constant across the board from the smaller size to the larger size in that range. All right, we're on to E, the ends or the couplers. So obviously the function of this is to connect the hose to the port. So the common sealing methods typically going to sort of narrow down into a few, itemised down below. Excuse me. Right, so thread interface. So we'll start on the top left-hand image there is generally speaking a taper style of arrangement. So NPT being a very common one, BSP taper as well as another one, where they're using the thread interface to create the seal. The middle image on the top row is what we call a mated angle or a seat mate. So you have a cone, as you can see there, which when screwed together, they meet face to face and create the sealing joint. On the right-hand side, we've got the two images with O-ring, with the arrow going up and down. The top image with the O-ring there is what we call O-ring face seal or flat face. So there's an O-ring which inserts into the groove there. When screwed together, the O-ring is compressed against the flat face on the opposing side. And below in the O-ring is what we call UN O-ring or boss O-ring, some people refer to it as. So that's screwed into the port and the O-ring is sealed against the taper machined into the block. I've also included another couple on there, which we do see here quite extensively now. We'll go for the middle bottom, which is the flange style, which obviously is quite common on a lot of machinery. Obviously, here, low pressure and high pressure aspects of this, you have different flange names. So you have a code 61, a code 62, a Caterpillar flange, Komatsu follow some of the code 61 and code 62, but also have their own sizing and particular ranges. Same as Liebherr loaders, they do the same thing. They have different thicknesses of the flange, but they all work on the same principle, that they have a flange face with a recessed groove machined in for the O-ring to be seated in there. And then they have clamps which go over the outside to hold the flange firmly against the face of the port and the block or the valve, depending on what the application is. Over to the bottom left-hand side, I've included some information on the metric style. Now, metric is becoming more and more common. It's very, very common out of Europe. The Germans do a lot of metric style fittings there, and we're seeing more and more in our day-to-day work. So I've included what the males are, then obviously all the females. Now, the females can come with O-rings. The females can be the tube with a nut and olive included on there. Now that can be manufactured, and the nut and olive is seated and it bites into the tube to create the seal. And then there's a universal style as well. So there's the female with a 24-degree or 60-degree cone. Now, as we say, we're seeing more and more of those. They're based on a metric thread pattern, and the sizes are based on metric threads or the tube OD. So something which does take a little time to get around, because they have also what you call a light series and a heavy series. Obviously, the light series does the lower pressures, heavy series does the increased pressures. All right, D for delivery. Now, this is sort of itemised out in two different areas. So one of them is the delivery of the fluid. So it's the velocity, and it's making sure we're getting the proper size hose to match what the velocity of the fluid needs to be. And the second aspect of it is the delivery of the assembly. How critical is it for the assembly to be where it needs to be to avoid any unwanted downtime? Generally speaking, if someone's had a failure, they want something as quick as they can to get back going again, because downtime costs money. So there's options there of a mobile service, or someone can come into the shop and pick it up, or again, if you have a mobile service out on site, you can make the hose as required on site. So through the stamped process, there's a lot of fact-finding questions in here. So, excuse me. So we've gone through a lot of these. We've run over these. So like the size, what is the size of the current assembly, what's printed on the lay line, temperature. So a lot of the questions, internal, external, what's happening there, how long has the hose been in place for, which we're replacing if they know. Application, go for all the application style of questions so we know what is the correct hose we're going to replace it with. The material of all the, which is fluid being conveyed, and always go back to that question of if they say it's just hydraulic oil or what kind. So it's always the what kind question for the material side of things. The pressure, just knowing what the system's working at, knowing what the spikes and what the maximum pressures could be. If somebody has changed the relief valve settings on the machine, that somebody may know about or someone doesn't know about, to understand why. And also, obviously, pressure, as we've said, works as suction as well for a vacuum. So the ends we've just gone through, what the sealing methods are. Some people can identify these, some other people need a bit more help with that, which is understandable. And, excuse me, if there's O-rings and how the ends are sealed together. And the delivery, as we just talked about, is why is the hose being replaced? How long does it last? Is it flow rate correct? Are we putting the right hose back? You know, what's the cost of the downtime by making a bad copy of a bad copy? So this is why we ask a lot of these questions. So hopefully after sort of the last 25 minutes, half an hour, everyone out there will have a bit more of an idea about the industry specifications and the differences between the SAE and ISO specifications. and also the stamped process. So obviously the sizing, temperature, application, material, pressure, the ends, and the delivery side of things. Again, all of this information is in the Gates catalogue. We can either have hard copies requested and delivered, or via the Gates website you can download the latest 2019 catalogue, and it has all of this information stamped and how to follow through this. So that does bring us to the end of today's webinar. If there's any questions or comments, please, you can type those in now. I'll have a look in a moment. If not, we're directing questions and comments to Kent Clark, who's our National Product Manager for Gates here for Australia and New Zealand. So, yeah, send anything his way if you'd like to. And if you'd like to join any of the upcoming ones, in 2 weeks, we have the next instalment on the 21st, which is coupling construction and failure mode. And then 2 weeks after that, we have the introduction to the thread identification. So that'll give you a bit more of an insight into what we were talking about a couple of slides ago regarding the coupling, the end styles, and how that all works. So I'll just have a quick look now to see if we've had any questions. No, there's nothing come through as of yet. Please, if anyone does have anything they would like to know, feel free to type one in now. And obviously, with everything that's going on with COVID right now, Gates is here in any way we can do to support you in your business. So we can do a lot of things, video conferencing, like phone calls and emails as a standard. Yeah, we can use a platform which we have as for these webinars where we can get a lot of people online and have a discussion and yeah, promote what Gates can do and how best to get that to you. So yeah, feel free to jump on and request a meeting, and we'll be in contact as need be. I'll just have another check for any questions. No, there doesn't seem to be anything coming through at the moment. So with that, I know we sort of expect for an hour, but you know, sort of half an hour gives us a good overview of what we were talking about here. We might finish it off there. But feel free, as I said, to any questions, send them through to Kent Clark or get in touch with your local Gates Business Development Manager. More than happy to answer anything, and we'll take it from there. Thank you for your time.